In example 3, we need to write both a sine, and I'm going to do the sine in purple, and a cosine equation for the graph. So let's try the sine first. So we've got y is equal to, we need to figure out what the amplitude is, and then we can also figure out the vertical shift at the same time. So what I do is I just draw myself a top line, I draw myself a bottom line, and then I figure out what's smack dab in the middle. So it appears that this bottom line is -1 here. This is 4, 3, 2, 1, and 0. So right in the middle of -1 and 3 would be this line right here, and there's your vertical shift. So the vertical shift is there, the amplitude appears to be 2. There's plenty of ways to write these. You can write it with a reflection or without. We're going to try to write this, well, let's see, if we shift left or shift from here to the right, then we'll need a reflection piece as this one's going to start down. So let's do that. Let's write our -2, and you can come back and change that if you need to. And then we'll do sine. We need to figure out what k is, and then c, and then we said this shift is up 1. Matter of fact, for the cosine, it's going to be the same. We can figure out if we want to use a reflection or not. Actually, for this one, I don't think that would be quite necessary. So you could even start writing your cosine one if you wanted to right now, 2. So we'll just do regular 2. We can come back and change it, put a negative sign in there if we need to. And then we'll leave this spot blank, and it's still shifted up 1. So there are some things that will be the same here. The amplitude's the same for the graph. The vertical shift is the same. That won't change. Let's go back here to the sine equation though. And it appears we need to figure out the period of this thing. Oh, and that won't change. That'll be the same for each one too. So the period appears to be 4 pi. So if we've got, oops, this is a little below the, there we go. Maybe you can see this on wherever you're watching this. There we go. And let's see here. So 4 pi is the period. That's equal to 2 pi over k. And we could multiply by k on each side. So we'll have k, 4 pi times k is equal to 2 pi. So multiply by k. I'll show that for you there. And then we could divide by 4 pi. Move that up just a skosh again for you. And so we get k to be 1/2. And that'll be the same here for this one too, actually. So you could, the only thing that's different is the phase shift. So you could write your x or your theta over 2. And then now we need to figure out where to shift a nice sine curve. So if I draw a point here, we want to start right at the midline for the sine curve. And I drew a point down here, and then up here, and then over here. This graph would have a period of 4 pi, and it would not have any phase shift at all. So here this continues on, this keeps going on. So this graph right here without any value there would be this purple dashed one. We want to figure out how to get all of these points onto this graph, the one in black. So what we can do is we can ask ourselves how far is this point from this one, and if we can shift right by that amount, then all of the other points will actually shift on there as well. So it looks like from 0 to pi is pi. So the phase shift is going to be pi, and it's going to be to the right, so this should be a negative sign. That's going to be equal to c over k. We'll multiply by 1/2. So pi over 2 will be the value of c. So that's going to go right here. If you want to double check yourself, you could actually pick a point that is on the graph and see if it works. And this is actually a really good idea. Let's try that. I'm going to try that in some open space up here at the top. So I'll move this back down, and you can still see the equation that we've got written down there. So what would happen if we want to know what is y, or, well, y is 1 here, so 1 is equal to -2, and then we want the sine of pi over 2 minus pi over 2, which is 0, and then we'll add 1. So the sine of 0 radians, or 0 degrees for that matter, is definitely 0. If we think about our knowledge from the unit circle, here's 0, and then the y value is none, or 0, and that's the sine. Then we're going to add 1, so we get 1 is equal to 1. So this one does work out. If you shifted the other way, though, if you shifted incorrectly, you said, hey, maybe I'm going to go from the real graph onto my helper graph, which would be wrong, then actually this point should line up here and it should work. So we also could make sure that perhaps this point would work. So if we substitute 0 in, we've got 1 is equal to negative 2 times the sine, oops, don't need that one there, need this one here, sine of 0 over 2, which is 0, and then we've got negative pi over 2 plus 1. Remember that the sine of negative pi over 2, which is straight down on the unit circle, that's negative 1. And then we need to add 1, so we've got 1 is equal to 3, oops, excuse me, yep, 3, that's right, negative 2 times negative 1 is 2 plus 1 is 3, I got it. And so this one actually is true, and here it's not 1. You'll notice that I made a small error there. That was my helper graph, so kind of made a boo-boo. We want to go right to this graph, and we know that that y value is definitely 3, so this does check. So all the points check. Let's focus then on the cosine, and the cosine is going to have the same period, so the value of k here should be the same, so we could do x. If you prefer theta, you could use that. I like to throw in each one of the variables because you're going to see it written each way. And we now have to figure out what value of c is going to go here. Well, let's take a look. If we draw a helper graph, we would normally start here anyway, and then come down to the midline for cosine, and then come here, and then come back up. If you terribly wanted to put a value of c in here, then you could also just shift right or left by 4 pi. That would be fine, but there really is no shift for this one. All the points line up on it right away. So it turns out we didn't need the space here. It's a bad idea to leave a blank like that. So let's clean this up a little bit. We're going to make this x over 2 and then plus 1. And for this one, there really is no shift, but you could shift it 4 pi to the right or to the left, that's fine, or anything, but anyway, not necessary. So there are our solutions. You could check this blue one just the same as you checked the other one.